This is your Module 6 review. If you haven't already, I'd like you to take about 20 minutes to go through and work as many of the problems as you can. So turn off your video now and do that if you have not. To graph this particular graph, I need to remember that I need to find my starting point because it is a square root. It starts and it goes. It's a wave. It's what I call a wave. Opposite, and then I keep. So my starting point is going to be at -6, -4. My slope, or the number in front of my radical, is 2, so I'm going to go up 2 and over 1, up 2, over 3, up 2, over 5. That's my step function, 1, 3, 5. And it creates my graph. Excuse that interruption. So it creates my curve. Now I need my domain. My domain are my x values. I'm starting here at -6 and I'm going to the right, so I'm going to all of these positive values as well. So x is greater than or equal to -6. Now I need to do my range values. Your range are your y values. So I'm starting here at -4, and you'll see that my graph is going up. So this is y is greater than or equal to -4. I have graphed my function and I have identified my domain and range. Now for problem number 2. Again, it's a square root, so it's going to be a wave. Opposite and keep. The opposite of what's inside is my 3. I keep what's on the outside. Well, there's nothing there, so that's going to be a 0. So the starting point for my wave is going to be at 3, 0. Again, it's 1, so up 1 over 1, up 1 over 3, and it creates my wave. My domain for this problem is going to be x is greater than or equal to, well, it starts at the 3, which is my x value of my starting point right there. And my range are my y values, and you see it starts at 0 and goes up. Again, it's this value there. And so that is my graph and my domain and range. Let's go to our next problem. It's a cubed root. Opposite, keep. So the opposite will be -5. And I keep what's out here, which is nothing. So at -5, 0. Now, a cubed root is my wiggle. It does a little wiggle. And that's what I'm going to be looking for. So I put the 1 in front. It tells me I'm up 1 over 1 and down 1 and back 1. So I do my wave to the left and my wave to the right. I go side to side. My domain, therefore, since I go through all x and y values, is all real numbers. My range, although it doesn't go down very far or up very far on our graph, it is also all real numbers. My domain and range for cubed root problems is all real numbers. Problem number 4. Problem number 4 is also a cubed root. So it's going to have the wave. So I do the opposite of what's inside. So that's 2. And I keep what's on the outside, which is -2. 2, -2 is where my wiggle will occur. Again, up 1 over 1, down 1, back 1, and I create my wave to my domain. Again, is all real numbers. My range is all real numbers. So I have now graphed square roots and cubed roots. Next, we will begin solving equations. We'll be solving equations. Excuse me, let me zoom in just a little bit so we have a little better view. This 7 on the outside is being multiplied, so I have to divide by my 7. I will divide both sides by 7 because that's the inverse operation. So I get the square root of 12 minus m is equal to 2. To get rid of a square root, I square both sides. I must square both sides. So that leaves me 12 minus m equals 4. And I must continue solving my equation. Sorry. So now I need to subtract my 12. Negative m is equal to negative 8. Let me rewrite that over here to the side. I've kind of run out of room. And I have to finish solving that by dividing by negative 1. So that m equals 8. Now to check for extraneous solutions, I take my answer and I plug it back in to make sure that my problem works. So 7 times the square root of 12 minus 8 needs to equal 14. 12 minus 8 is 4. The square root of 4 is 2, so 7 times 2 is 14. It works. 8 is my solution. Let's look at the next one. Again, I have a square root. I only have 1, so I need it to be all on its own. So I'm going to subtract my 5. So I get the square root of 17x plus 2 is equal to 6. To get rid of a square root, I must square both sides. So I get 17x plus 2 equals 36. Squaring and square root cancel each other out. Again, I'm going to write it over here to the side so I can continue working. I'm going to subtract 2. 17x is equal to 34. Divide by 17, and I find that x is 2. I take that and plug it back into my original equation. 17 times 2 is 34, plus 2 is 36. The square root of 36 is 6, plus 5 is indeed 11. And so my answer checks. Let's go to problem number 7. Problem 7. Again, I only have one radical, so I need to get it by itself. So I have to get rid of the 4. So I'm going to add 4 to each side. 6 is equal to the square root of 16 minus 2p. I need to get rid of that radical, so I'm going to square both sides. That leaves me with 36 is equal to 16 minus 2p. I need to finish solving that. And I solve it by doing the opposite. 16 is positive, so I need to subtract 16. I get 20 is equal to negative 2. Divide by negative 2. And I get that p is negative 10. Again, check for your extraneous solutions by plugging it back in to my original problem, and you'll find that it does work. Let's look at problem number 8. Problem 8, I have two radicals, and they're on opposite sides of the equal sign, which is what I need. So to solve this, I'm going to square both sides. When I square the square root, it are inverse operations, so it goes away. 7 minus 2p equals 2p minus 1. You'll notice I have variables on both sides, so I must get rid of one of them. So I'm going to add 2p to both sides. 7 equals 4p minus 1. Again, I need to continue solving that. So I'm going to add 1 to both sides. 8 is equal to 4p. Divide by 4, and p is 2. I plug that back into my problem. 7 minus 2 times 2. So 7 minus 4 is 3. So that's the square root of 3. Now when I plug it in here, 2 times 2 is 4, minus 1 is 3. So I get the square root of 3 on both, and so it checks. It is correct. But that's what you do. You check it to make sure that it works. Let's go to problem number 9. Again, I have radicals on both sides, so I have to square both sides to get rid of the radical. When I square both sides, I get x plus 6 equals 12 minus x. I'm going to add an x to both sides. 2x plus 6 equals 12. Subtract my 6. And I get that 2x equals 6. I've run out of room, so let's go over to the side and finish. Divide by 2, and x equals 3. Again, I plug back in to make sure that this answer works. The square root of 3 plus 6 is 9. The square root of 9 is 3. Then that needs to equal the square root of 12 minus 3, which is also 9. The square root of 9 is 3. And my problem checks. I have done that problem correctly. Now, problem 10 is a little bit different. You'll notice there is only one radical, but there is a variable on both sides, which is going to create a different kind of problem. So to solve my problem, I need to get rid of the radical. Since this is a square root, I will square both sides. Squaring the square root gets rid of it, so I get negative 48 plus 14p is equal to p squared. Since I have a quadratic, a p squared, I want to make this equal to 0. I'm going to subtract the 14p and then add the 48. Zero is equal to p squared minus 14p plus 48. Here's where I have to do something a little bit different for this problem. I need to factor this side. You should remember factoring. If you don't, here's a quick reminder. We're going to break down our middle term so that we have 4 terms, so that we can group the first 2 and the last 2. So in this problem, I need to think what multiplies to give me 48 and adds up to negative 14. And adds up to negative 14. Well, if I think I have 2 and 24, not going to work. 4 and 12 will not work. 8 and 6, oh, that comes very close. It's going to be negative 8 and negative 6. Negative 8 and negative 6 multiply to give me positive 48 and add up to negative 14. We'll continue this on our next video.